Good morning, everybody. It's great to see you here again. I'm going to try in the next few minutes to do a concise introduction to turning and a discussion of a lathe, which is the primary machine which does the turning operation. Now, turning is one of the, in my loose classification scale, one of the three primary subtractive machining processes. Subtractive machining means take a block of material and remove all the material you don't want, leaving behind the part that you actually do want. Like, think sculpting. Turning is fantastic producing cylindrical parts or parts with helical threads on, and it involves when the stock of material is spun and the tool remains fixed. Now, the other two processes are milling, where the stock remains fixed and the tool spins against the stock, and drilling, which is where you can do it either way, but is producing round holes. We will talk about those in other videos, but turning is our focus now. Just for all of you lawyers out there, please understand these are fairly loose classifications. There are a million different machining processes in the world. Millions of them, and many of them blur the lines between these. And even lathes typically are very good at drilling in certain circumstances. And we have lathes which are good at lathing and pretty good at milling. And you'll find out a mill can do a pretty good job in turning as well as milling as well. So it's all kind of a mess. But broadly speaking, turning, milling, and drilling are your three primary processes. So let's quickly go into definition of the lathe. That's the primary machine which does turning. And from the Oxford English Dictionary, we have a definition which is a good one. It's a machine for shaping wood, metal, or other materials, and it rotates the piece being worked on against changeable cutting tools which stay fairly fixed. So again, the stock spins against fixed tools. Now, the brief history of the lathe, they go back as far as ancient Egypt in the archaeological record. Probably just means we haven't found others, but I bet you it goes back further than that. It is considered the mother of machine tools for some very good reasons which we'll get into later. But I think it fascinating that in the modern age, David J. Gingery produced a series of books on him's making machinery from scrap and scratch. And his first book was building a charcoal foundry to make castings. The second book, as you can see, is building the metal lathe. And then he goes on to build the rest of the machines using the foundry and the lathe. Now, the reason is the lathe has some excellent properties, but I would highly recommend you get a set of his books. They're fascinating for anyone who wants to actually understand what these machines are and how they're made, and also kind of how to make them from fundamentally first principles. So, the lathe is considered the mother of machine tools, and let's take a look at a lathe for a moment. This here is a classical manual lathe, and a CNC lathe is computer controlled, where you'll find motors replacing the human operator for the various operations and a computer driving the motors. But they're pretty much the same. So what do we have? We have a rotating drive on the left side with work holding. Now there's a joke in dancing, which is there's only two problems in dancing, the music and the steps. Well, in machining, there are only two problems in machining: holding the stock you're working on and the tool you're using to cut it. So the work holding is on the left, and in this case there's a 3-jaw chuck. The work holding is also at the other end of the bed in the tailstock, which we will talk about for longer bars. So basically, for short pieces of stock, you would hold it in the chuck or in the collet, and you would have a piece sticking out, which you would then bring the tools in via the tool holding, which is the saddle and tool post in the middle, and you would use it to cut into the piece. As soon as that bar gets quite long and you're spinning it quite fast, I'm sure you can understand that the bar has a real incentive to go off-center. And I'm sure you know how centrifugal force works. The more off-center the bar goes, the stronger the force that bends it off-center is. So one of the classic ways, sadly, to get hurt using a lathe is a long unsupported bar. Because basically, as soon as it becomes a little off-center, it will go very off-center very quickly, and if it hits the bed or hits the operator, it's a very bad situation. So, for the longer bars, what we do is you would clamp it in the work holding, you would replace the tailstock pin with a drill, you would drill a small hole in the center of the work holding as it spins, and then you'll put the pin back in, and as you can see it here, and you would have the bar sticking out of the chuck, and the tailstock pin would be stuck in the hole at the end of the bar, and now it's held at both ends. And then as it's spun, although there's still an incentive for it to bend off center, it's it's held at both ends, so the end can't come free, and then you can machine much harder and in much more consistent way. So please bear in mind that tailstocks are really important for any kind of long unsupported milling operation. So just to recap, motor and work holding on the left, tailstock on the right, and the saddle in the middle, which travels up and down that straight edge of the bed and carrying the tools with it. So why is the lathe great? We've talked about it as a mother machine. We've talked about it as in its anatomy, but let's get to the heart of it. The lathe leverages just a couple of straight edges in the bed and the rotation of the motor and the work holding to create perfect cylindrical parts. If you accept that nothing is ever straight or perfect in real life. But fundamentally, you can make straight edges just by hanging a piece of string with a weight on the end. That gives you a very straight edge. Rotation is really easy to do. Combine the two and we can now produce these arbitrary cylinders, which are pretty much the foundation of most other machines. I've put some photos, beautiful photos of things that I've made on a lathe. Look at them. Their main property is a cylindrical, this perfect circular cross-section. So it's fundamentally good at this kind of work. If you have a cylindrical part that you need to make with a profile on it, the lathe is the equipment for you, and the turning is the process that you need. So lathes are phenomenally good at just requiring a few simple things to suddenly produce a whole family of powerfully useful parts. I mentioned before that no machine is ever quite as simple. So lathes also typically supports drilling on center, which is where you would bring in the tailstock with the drill in it, and you would be able to cut holes in the center line. Let's go have a look at the computer controlled version briefly for a moment. If you can see in the video here, you can see it facing and doing an outside diameter cut, and then it's just about to bring in the drill. So you can see the drill is fixed, it's spinning it against the drill to create that perfect central hole. So computer-controlled lathes are used in production environments where you're making thousands of parts that are the same, or even thousands of parts that are different, and it does things precisely, very high tolerance, it doesn't get bored or tired, and it is a mainstay of modern manufacturing. We actually have two at the Bechtel Center, and they're very, very useful machines. I wanted to briefly talk about computer-controlled lathe coordinate systems. So in a standard mill, the coordinate system is X, Y, and Z, which you're probably familiar with from all of your kind of math type classes in high school, where X is along, Y is up, and Z is depth. Now, in a mill, that's typically lying flat on the bed, but in a lathe, it's kind of different. You only have two axes. You have the Z-axis, where positive Z is away from the spindle, and positive X is away from the axis of rotation. So Z is, another way of putting it, is along the line of rotation, that center line around which the cylinder spins, is your Z-axis, and then the X-axis is how close to that center line you come. Now, the CNC lathe has a turret in it holding multiple tools, of which one is going to be brought in contact with the part at a time, and the tools are held in the black metal blocks, and these are all switch changeable, so you can switch them out to support different kinds of tooling and different kinds of parts. But it's very similar to that manual lathe. It typically has an outer shell on it because it throws less small chips of metal around the room that way, but typically that's what we're looking at here. So that's the end of our introduction on lathes, why lathes are great, and some of the kind of features of a lathe and some of the reasons why you will want to use it.